Hi everyone, I am Sneha, co-founder and CEO DevCompass, and as always I am super thrilled to have you guys here. We have reached the end of stage 2 videos, and I hope that everything that we have learned in stage 0, 1 and 2 throughout these videos and walkthroughs in the assignments, you are following it really well, and it's all there, it's all fresh, and you understand things from the core of it, and yeah, you're having fun. That's all I can hope for, and everything else is secondary. I think it's super important to have fun while you're learning. For all the people who don't know what I am talking about, please head over to devcompass.ai and you will get all the relevant information about the course. Please show us some support. And let's get started for today's video. So in this entire series, I think we have discussed a bunch of things, from Claude's first conversation to tool definitions to error messages to context window and whatnot. And the last video was a lot about hooks and how you can reduce the entire probabilistic and deterministic side of things by writing code that checks every time it runs and saves you money and can be used during business rules and so on and so forth. So every tool that we have built in this course has been defined inline and has been written directly into agent code. That works perfectly well for a single agent with a very small set of tools like we discussed last time. But I want you to think about what happens when you scale. If you have 20 tools, you have 3 different agents that all need access to get customer. You have a tools team and an agent team, and they're different people. Suddenly inline definitions become a maintenance problem. Every agent has its own copy of every shared tool definition, and when something changes, it changes in multiple places and you don't always remember to update all of them. And that is why we're going to talk about the solution to that problem, MCPs, the Model Context Protocol, and why does it really matter. Adjusting slides. Okay, yes. So look at the architecture diagram on screen. There are 3 components left. Is the Claude, the host, the client, this is your API agent, or Claude Code or any other Claude-powered system. It needs tool to do its job. The right side is the actual service your tools talk to, the customer database, the order database, the payment API. These exist regardless of MCP. They're just your backend systems. In the middle is your MCP server. This is a process you run, your code that sits between Claude and your backend services. It exposes your tools in a standardized format over what is called the MCP protocol, a standard JSON RPC interface. Claude connects to its server, asks it what tools are available, receives their definitions, and from that point on calls them exactly like it would call any inline tool. There's no different from Claude's perspective. Look at where the plug and socket from the title card now sit. On the protocol arrow in the center, connected. That is the visual payoff. The plug is Claude. The socket is the MCP server. The MCP protocol is what makes them compatible. It is standard, so any MCP compatible client can connect to any MCP compatible server. Claude sees all of these tools. It does not see the server. It does not see the databases. The MCP server is an abstraction layer. From Claude's perspective, as I said, it's just a list of tools with descriptions, same as how inline tools are. The difference is entirely in how you manage them and what's behind that list. So let's see what's next. Let me show you how to Let me show you the maintenance argument concretely, because this is what makes MCP worth the setup cost when you're working at scale. Look at the left sketch. 3 agents all defined inline. Agent A needs get customer, lookup order and process refund. Agent B needs get customer and lookup order. Agent C needs get customer and process refund. Each agent has its own copy of the tool definitions embedded in its own code. Now you need to update the get customer description. Maybe you have added a new input field, or you have refined the boundary description based on something you learned from video 1. How many places do you update? 3. And if you forgot one, or if someone else on your team updates their copy slightly differently, you now have 3 agents with 3 different versions of the same tool definitions. Which copy is correct? The question mark on the left sketch is there for a reason, and that points literally that. Now look at the right side of the screen. Same 3 agents, but now each one just has a connection arrow pointing to a central MCP server. The tool definitions lives in the server. One place, update get customer in the server, and all the 3 agents get updated definition and in just the next connection. One source of truth. But, and I want to say this clearly so you don't overcorrect, don't use MCP just because it exists. If you have a single agent with 5 tools and you're the only person working on it, inline is fine. The setup overhead of running an MCP server is real. It earns its cost when you have multiple agents sharing tools, or when tools are maintained by a different team from the agent, or when you need strict versioning and auditing of tool definitions. Now, the 2 configuration concepts the exam might specifically test is project level scope and user level scope. Okay, so the config file is .mcp.json and it lives in the project root. It is checked into the repository. When a team member clones the repo and runs the agent, they automatically connect to the same MCP servers the rest of the team connects to. The tools are shared, the server addresses are shared. This is for production tool that everyone on the team needs. Your customer database connection, your order API, your shared business tools, committed, versioned, consistent across the team. Then there comes a user level scope. The config file lives in your home directory, not in the repository. Not committed, not shared, only your Claude sessions connects to these servers. This is for personal tools, your development database, a tool that talks to your personal test environment. Something you're experimenting with that isn't ready to be shared, or for credentials, which will bring me to my next slide. But project level equals shared and versioned, user level equals personal and not committed. And I want you to hold that in mind when you see an exam question describing a team configuration scenario. But let's go to the credentials. Now, this is where most teams make a mistake when they first set up MCP, and it's a mistake with real security consequences. If you look at the version A on the left, the wrong way, the MCP config file contains the API key directly. API key, SK, ABC, 123, whatever, hard-coded as a string. The config file is committed to the repository. That means every person who has access to the repo, and potentially anyone with access to your version control history, can see that key. When you rotate the key, you have to edit the file and commit the change. If you forgot to rotate it after someone leaves the team, the key is still in the Git history even if you delete it from the current file. The annotation says it plainly. In the repo, visible to everyone, leaked when you push, and we have seen so many such API keys being leaked on the internet. Now, version B is the right way, the correct way. The config file doesn't contain the key. It contains the name of an environment variable, let's say environment customer DB API key. The key itself lives in each developer's local environment. The config file commits safely. There's nothing sensitive in it. Each developer sets their own environment variable with their own key. When someone leaves, you revoke their key. The config file doesn't change at all. The annotation, config commits safely, key lives in environment only, so each developer uses their own key. The rule is super simple. Never hardcode credentials in MCP config files. Always reference environment variables. That rule applies to both project level scope and user level configurations. But it matters most for project level because those are the ones that actually get committed to GitHub. Now, the last concept for this video is scoped access, and this one connects directly to stage 3. So pay attention because you're going to build this exact architecture in the next stage. Look at the 3 agent boxes on screen. 3 agents in the same system, each configured to connect to different MCP servers. First, the customer lookup agent. It connects only to the customer DB server. The only tool it has access to is get customer. It can read customer records. That's it. It cannot touch order. It cannot touch payments. The order agent. It connects to customer DB and orders DB server. It has get customer and lookup order. It can look up customers and their orders, but it cannot process refunds or touch the payment API. Agent 3 is the refund agent. It connects to all 3 servers. It has all 3 tools. It's the most trusted agent in the system, and it's also the most scrutinized because it has the most power. Now we talk about blast radius. That's the term for what happens if an agent is compromised through a malicious user input, a prompt injection attack embedded in a tool result, or a bug in the agent code. If agent 1 is compromised, the attacker has access to only customer record. That's bad. That's bad. But they cannot process refunds because agent 1 has no connection to the payment API. The damage is bounded by the tools that the agent can reach. So blast radius is limited. And if this happens, maybe the malicious attack or user input happens to agent 3, then a lot of things are compromised. So scoped access through MCP is not just organizational hygiene, it's a security property of your architecture. The less access each agent has, the smaller is the blast radius. If something goes wrong, everything's gone. So design your MCP connections with that principle in mind. Before we close, we need to look at the updated scenario diagram on screen, and this is the diagram we have been building since stage 1. The customer support agent with the customer database and orders database. Now we have added everything including the stage 2 contributor. So the hooks layer sits between agent and the tools. Again, the ambered bordered box you now recognize as your enforcement layer here, with the pre-tool use and post-tool use hook icons. The tool definitions have moved out of the agent code and into an MCP server box connected by the protocol arrow. The return arrow now carries a label structured errors because that's what comes back when things go wrong, and process refund has joined the tool set in the MCP server with the $500 gate annotation showing that the escalation hook is active. So all of these, for you to actually join the dots, it is very important that you've gone through all the previous videos because we are kind of building it in stages. We started with customer, then the interaction with Claude, how does the whole agentic system works, then how did hooks come in, how did MCP server came in, how does structured error works, context window, all of it. So this was stage 2 complete. Tools are trustworthy, hooks are enforcing, MCP is exposing. So when you come back after for stage 3, we are going to add to this diagram again a coordination layer which would be sub agents running in parallel, and everything that comes with scaling to multiple agents. So this diagram will grow with us across the course. That was all about stage 2 and MCPs for this video. So we defined tools 1, expose via standard protocol, and client connects. Multiple scopes, project level, user level. Project is always shared, user is personal, and in order to actually keep your data safe, you need to give scoped access so that it maintains organizational hygiene. But yeah, that's stage 2 for you guys. 5 videos. We started with a customer support agent that worked in ideal conditions, the one that you built at end of stage 1. We have now given it proper tool descriptions that eliminate any non-deterministic routing. There is structured error responses that let Claude act instead of getting stuck. Programmatic enforcement of business rule, that is 100% rather than 99%. Hooks that intercept tool calls at 2 specific points without really scattering checks across the code base. And in the end, we had MCP that exposes all of those tools in a standardized, scalable, and secure way. Now, the one more information which is very important for everyone taking the course is that the stage 2 capstone walkthrough is going to put all 5 of those things together and run the agent through 5 test scenarios, including a mid-conversation timeout, an attempted refund bypass, and a date normalization case. So do all the walkthroughs before you head over to stage 3. When you come back, we will be scaling to multiple agents, which introduces an entirely new category of problems that doesn't really exist in single agent systems. So I will see you in the next one. Thank you for watching.